Okay, college algebra, let's finish up 1.4. The part in the quadratic formula under the square root, the b squared minus 4ac, is called the discriminant. It basically determines, of course, if you have a negative under the square root, that's when the i's take place. If you have complex roots, imaginary ones, or real roots, or possibly a double root if there's a 0 under the square root, because then you're adding and subtracting the same 0. So you can use that b squared minus 4ac to determine the kind of roots you're going to have. So if it asks you what kind of roots the following quadratics are going to have, all you have to do is take b squared minus 4ac and look at it, how it compares to 0. So that would be 4 squared minus 4 times 2 times 5, which is 16 minus 40, which is negative 24. What do we know about negative 24? It's negative. That means there would be a negative under the square root, which means you have two complex roots. Now, if you look at this equation, this is the same one from the previous video, and we saw that it did indeed have i's in the roots, so they were complex. So let's look at 3x squared plus 18x plus 27. Now, my suggestion to you is you can use the b squared minus 4ac on this, but if you can divide everything by 3 to make your life easier, go ahead. It won't change the kind of roots you have if you divide by a constant. So b squared minus 4ac again, so that's 6 squared minus 4 times 1 times 9, or 36 minus 36, which is 0. If you have a 0, that means you have a double root that's real. What that means is, like, if you have a parabola, which is what these look like, it's like it's sitting on the axis and either going up or down to have a double root. Okay, so there are other factoring techniques besides just factoring a quadratic formula and completing the square. Sometimes instead of having a quadratic, you might have a cubic. You may need to use the sum or difference of cubes. This is really primarily a formula you're just going to have to get used to using. So the sum of cubes is if you have two things that are perfect cubes, they can factor into a plus b, and a squared minus ab plus b squared, and a cubed minus b cubed is a minus b times a squared plus ab plus b squared. So the easiest thing to do here is you look if this is a perfect cube. Is 8 a perfect cube? Yes. Is x cubed a perfect cube? Yes. Together they're 2x cubed. Is 125 a perfect cube? Yes, it's 5 cubed. Which means in this case my a is 2x, my b is 5, and the minus signs mean I'm using difference of cubes. Now it says the first parentheses is a minus b, so that would be 2x minus 5. And the second parentheses is a squared, so a is 2x, so this is 2x squared, plus a times b, so 2x times 5, plus b squared, plus 5 squared. And we can clean this up. 2x minus 5 times 2x squared, so 2x times 2x is 4x squared, 2x times 5 is 10x, and 5 squared is 25. You can check it by using the distributive property, but it will get back to 8x cubed minus 125. And from here, what you can do is, if you are trying to find roots, instead of just factoring, you can set these equal to 0 to find potential roots. Most of the time, this will give you a real root. This one, you could use the quadratic formula, but it may not necessarily give you a root. Most of the time, it will give you imaginary roots, because they're not usually factorable over the reals. Let's try this again. 27x cubed. This is 3x cubed, because 3 cubed is 27, and x cubed is, or x cubed is x cubed, and 64y to the 6th is 4y squared cubed. There's a plus in between. So in this case, my a is 3x, my b is 4y squared, And I can use this to use my formula. Since there's a plus in the middle, we'll use sum of cubes. So that first parentheses is a plus this time, 3x plus 4y squared. Second parentheses, 3x squared minus 3x times 4y squared plus 4y squared squared. Clean it up, 3x plus 4y squared times 3x times 3x, 9x squared, minus 12xy squared plus 16y to the fourth. There's no real way around memorizing these. There are usually some of these on the test, maybe one or two. You have to know how to do it. Lastly, solving the equations for the given variable. Let's take vk squared equals 2r and solve for k. I need to get k by itself, so I'll divide by v. K squared equals 2r over v. And then take the square root, so k equals plus or minus square root of 2r over v. It's exactly the same thing you would do with numbers, it just feels weird. And solve a plus 3b squared equals c to the fourth minus ad cubed for b. First things first, subtract a. Get 3b squared equals c to the fourth minus ad cubed minus a. Divide by 3. We get b squared equals c to the fourth minus ad cubed minus a all over 3. Take the square root. B equals plus or minus square root of c to the fourth minus ad cubed minus a over 3. So it looks weird, feels a little weird, but it's the same as before. You could simplify, do more, but we're not going to. And that is all for 1.4.